So above we said that summation an is said to converge if Sn is convergent. Okay, so Sn is the sequence of partial sums. Sequence of partial sums. What I forgot to mention is in this case, we write summation an is equal to this limit and goes to infinity. And a little justification for that is, well, lim Sn is equal to lim, what is Sn? Sn is A1 plus A2 plus A3 plus all the way up to An minus 1 and An. So again, Sn is the sequence of partial sums. So S4, so S3 would be just the first three terms. S4 would be the first four terms. S5 would be the sum of the first five terms. So I think it makes sense to say that in terms of definitions, oops. That when you take the limit as n goes to infinity of this expression here, okay, what you get is the full sum. Okay, we'll put this in a thought bubble because this is not entirely, how should I say, not the rigorous way of thinking about this, but it does help to understand this thing I'm putting a box around here. Okay, let's look at geometric, scroll up, geometric series. So these are series that have a very characteristic form. Okay, so you have in the series, you have this A appearing every time, and then you just have higher powers of R as you go left to right. Okay, we can summarize this. Summation, how does the book do it? So it goes n equals 1. Okay, I'll put this in orange here. Okay, I'm not always going to write this. So this is called a geometric series. Geometric series A and R are real numbers. So you could say A is equal to the first term, and R is equal to the common ratio. Okay, let's do an example. An example, Zeno. Zeno is a Zeno's series. is a geometric series. What was that? That was a 1 plus a half plus a quarter plus an eighth, and so on and so forth. Okay, I can write this as summation. Okay, so remember a is the first term, right? So that's, here's my a is 1. And r, well, if something is geometric, if it's geometric, I can take one term, say a4 divided by a3. I can take that's 1/8 divided by 1/4. What you get is 4/8, and you get a half. Now this will equal r. Now this isn't always, you can't always think about an arbitrary series like this, but a geometric series you can think about like that. So we get a half to the n minus 1. And of course, a is equal to 1. So r is a half, a is 1. So Zeno is a geometric series. Now, what can we do with geometric series? Well, thankfully, we can find the sum in many cases. Oops. So we have a nice formula. It is a over 1 minus r. If r is less than 1 in absolute value, and it's divergent otherwise. Okay, so I'll talk about that proof in my next video.